Good afternoon from Dubai. I'd like to welcome you all to this session using design of experiments DOE to improve quality. And we have an exciting and interesting coffee case. I know many people are usually alarmed by the design of experiments given its highly statistical nature, but I will try to simplify. We continue to use these experiments in many of the improvement and quality initiatives, including Six Sigma, where I teach the green belt and the black belt courses. We continue to use it during certain stages where we need to make decisions about screening, i.e. selecting the right variables that affect my output or Y. And sometimes we need to actually decide on the amount of the X's or the variables to actually achieve the optimum Y. Hence, we will use today a very powerful software called Minitab to understand how we can affect or improve the quality of something that we all hopefully take, which is one of my favorites, which is the coffee and espresso. So we will use now the beginning of the program here, of the webinar, to actually introduce to you the concepts of the design of experiments and the different types of DOE, and then we'll move forward and take a live example and use Minitab to actually look at the data and how it can help you evaluate the output or optimize the quality of any variable or experiment that we have. So without due delay, let's get started and move now to the slides. And what I'll do, I'll take you through the slides themselves. So the design of experiments, and we're using the coffee case. Now, just let me introduce myself. My name is Fawzi Bawab. I'm a partner and senior consultant with Meirc Training and Consulting. My career started with what I call an engineering background, where I hold a bachelor's degree in civil engineering. I hold also a master's degree in industrial engineering and currently preparing my doctorate in Lean Six Sigma from Edinburgh Business School in Heriot-Watt University. Before joining Meirc, I used to live and work in Ottawa, the Canadian capital, where I worked with KPMG Quality Registration Services and also with BSI, British Standard Institution. So my career expanded actually to look into the consulting, coaching, training, and application of quality principles, including the ISOs, including the Lean Six Sigma, and of course, the deployment of many of the organizational quality initiatives. I'm a member with a number of institutions, including the American Society for Quality, and I'm a certified Six Sigma Master Black Belt. I'm also wearing another hat in my portfolio here at Meirc, which is the strategy, where I continue to work and coach on strategy engagements and strategy deployment. What else? Leadership, strategic planning, KPIs, these are the areas that I focus on. I worked with a number of organizations, including the GEs, the Kraft Canada, General Motors, Sabic, Almarai, many of the companies in the region where I continue to consult and train on issues of quality and strategy. So our agenda for today will start with a discussion of what is DOE, design of experiments, why would we use DOE, and again, let me just emphasize on the point that we're not going to get into the statistical part, i.e., the complex statistics. We want to use DOE for a sort of an end or an objective where we can use DOE in our quality initiatives to understand how we can optimize the variables and use them in different initiatives. And we will use Minitab as a tool to do that. So actually the application of the concept, the understanding of the concept is my objective behind this session. Now, how would we run a DOE? We will see a live example, the different types of DOE, and what are the benefits, and then we'll take a practical example, and I have the coffee case that I have prepared for you. So why people fail in DOE, we'll talk about that as well. So let's move on and talk about what is DOE, what is design of experiment. Now, from the name itself, you know that there will be experiments to be conducted. You need to set up a plan to run experiments. So the design of the experiments for an objective that you will run through a structured methodology to change multiple settings in order to understand their impact. So assuming that you have an impact or a response or something that you would like to actually change or like to impact, the question is, what are the X's that you would like to have or you would like to actually change to have an impact, or whether optimization, reduction, or increase of your Y? This is basically the objective of a design of experiment. Now, when we think about the design of experiments, it's basically a study where the factors, now someone has to actually decide on these factors, and this is what we do in our projects in Six Sigma, where we define what is the Y and what are the X that affect a certain process. And then we would like to consider a variable or multiple of variables, we call them the Y, that basically we want to optimize or improve or reduce or decrease. And then we would like to define what is the statement of the objective. Would we like to have better coffee, more quality coffee, if you can quantify that? And we would like to run the experiments actually to do that through the design of experiment. So this is where scientifically the design of experiments presents you with what we call the analysis of variance. The hypothesis testing is being done in the background to ensure that there is a significant impact or a significant impact coming from your X's. And then, of course, the next step will be to find the amount of the X's that will give you the optimal Y. So basically, why would we use them? Well, we want to create information. We want to manipulate the input variables. We call them the X's. And, in a controlled conditions where we play with these variables and then decide what is the optimal X's that we want to have the Y. Now, once we get into the example of the coffee, we'll have more clarification on what are the X's, and when I say X's, and what are the Y's, so we can actually optimize on them. Now, how to run DOEs? Well, first of all, you should have some kind of a question or a problem on me. How can I improve something? How can I decrease of something? You should have an objective behind the experiment. Now, the output, or what we refer to as a response in our DOE, is what we want to actually have an impact on. And now, that response, we would like to have it in a maybe a quantified manner so we can actually measure it. So if you tell me, I want to improve the quality of the coffee, well, someone will say, well, how do you quantify the quality of the coffee? Would you measure bitterness of the coffee? Would you measure the aroma of the coffee? What are the quality indicators of coffee, and how would you measure them? So that's part of selecting the output and response. Now, someone will come and say, well, what makes a good coffee? A good coffee? Is it the type of beans? Is it the type of water? What can we play with to actually change the response and have a better response, whether you're measuring bitterness or coffee or however you define that? Now you need to actually define on the factors, and we'll talk about the different factors that you want to play. Are you doing multiple factors or one factor at a time? So this is where the design of the experiments, and this is where Minitab has a very nice feature called the assistant, and I'll show you that in a minute, where it sort of assists you. That's why it's called the assistant. It actually guides you through the experiment to actually build the collection plan, a sheet of paper where you can actually put all your data and you can fill it directly into the software or Minitab. You collect your data, you analyze your data, and then you draw a conclusion. And the beautiful thing about Minitab that many of the conclusions that you want to actually come with are already embedded within that assistant reports, we call them. So any testing where the inputs are controlled and the analysis has been planned, this is where we start to call it a design of experiments. The following slides actually shows you in detail what we need to do. We need to define the practical problem. What is the thing that we're trying to optimize or work on, whether we want to improve the quality of the coffee, or maybe increase the kilometers or mileage on a car using the best or optimal combination of tire pressure or gas, tire. or speed. So this is where the practical problem will be defined into a statistical problem where you are saying, here is my y, and y equals what? A function. So let me just get that here. So my function, right, of x's. I didn't get that right here. So let me try that again. Y equals, right? And here we go. So function of x's, and you have, of course, x, and then you have a number of x's, so you might have an xn. So this is where your x's are defined part of your equation. And this is where your key output or key performance output variable is defined as a response. So now this is where you have to define that variable that it's called the y, and how will you be able to measure it or quantify it? And then your inputs, right? These are inputs, so O for outputs, I for inputs. Basically, you're telling me what are these variables that will affect your y. Now, at this stage, we may not know which of these x's. I might have a list of a number of x's, but I'm not sure which ones are significant to the y. And this is where Minitab and the design of experiments can actually shed more light on this and can give us more information. Now, the next step is to basically choose levels of the input variables, select the experimental design, and Minitab will do lots of this because it will tell you whether you want to replicate this by 2 or 3 times, and the significance of the study and the accuracy of the experiment will, of course, be better as you have more replicas, but that means you have to run more experiments. Plan and allocate resources. You definitely have to allocate resources, including people, including material, because it's an experiment you have to run. I.e., if the experiments will entail that you run 16 runs, it means maybe you have to do the same thing with changing the variable 16 times. So whether you're making coffee or creating any type of an experiment, the experiment physically has to run. So that means resources, that means time, that means maybe funding or investment, depending on the experiment itself. So basically, in a graphical format, here's what we're trying to do. We are trying to define the x's. So here are the x's. 10, maybe we have 5, we have 6, depending on the team discussion. So this is more of a collaboration between the team who understand the process to come up with these x's. Now, how would you come up with these x's? Well, you may use a tool called cause and effect matrix or diagram. You might use another tool that we call the failure modes and effect analysis, or FEMA. You might use some techniques to understand the significance of these x's and to decide whether these x's have a significant impact. We call this testing the test of hypotheses, the null hypotheses and the alternative hypotheses. And this is widely used in statistics and other applications. And this is where we basically move to the next slide, where we talk about the design of experiments. And as you can see here, the 10 x's that I have here maybe have been screened or now optimized or selected as 3 variables. From these ones, maybe in our DOE, it will reveal that only x's 3, 7, and 9 are the significant factors that will affect my y. So this is where the design of experiments can come very handy for us. Now, the design of experiments types, we will talk about the 3 types. Screening is used to determine which of many factors impact the process the most. So as we said, maybe you have coffee and the output is the quality or bitterness of coffee, and you want to first brainstorm, discuss within your teams using some of the tools that we mentioned to come up with what we call the factors that have the biggest impact. Now, once we determine that, that's called screening. And Minitab has something in that will actually tell us that maybe factor 3 and 4 and 5 have the biggest among the 10 factors that we have. And then we have the characterization, which basically is used to produce the formula using only the most important factor. So think of it sometimes as a regression analysis, and you're trying to optimize your y and get the most out of your x's to impact your y. Of course, the last question will be, what are the amounts or variables that basically we have to define, or we have defined already in the screening, the X3 and X4 and 5. What is the amount, whether in time or weight, whatever the unit of measure that you are using to optimize these things. And we will use Minitab to take us through these steps through its very smart assistant. Selecting the inputs and output. For example, here someone is saying, I want to see, I want to get the most out of my car, in terms of kilometers or mileage. So someone will say, all right, well, what are the inputs that might affect that? Well, among that could be the speed. I mean, the speed itself will consume more gas and maybe get you to better kilometers. What about the octane type? I mean, you have different type of octane, maybe 90, 95, 99. What about the tire PSI? The tire itself, the pressure, will that have an impact on the distance? So if your distance is your output, what are the areas? Now, you may have other factors, we call them noise sometimes. They're continuous in nature, i.e. they're variable, the data, their temperature, they're on a scale, or pressure, or relative humidity. So again, they could be discrete variables or they could be continuous variables. Now, how do you come up with these inputs and outputs? A discussion within the team could be using the cause and effect matrix or cause and effect diagram to find out what are the drivers, what are the X's. So there is a discussion here happening in the background before we start the design of the experiment to design on the factors. So the selection of the X's, a factor, basically the one that will have an impact on the Y. Now, you may have quantitative factors, such as temperature, such as time. You may have qualitative factors where you say, type of coffee is A and B, or is it different machines, or type, or water type, is it tap or bottled water? So these are qualitative or attribute discrete data, right? And then you have the variables. So this is a discussion that happens within the team to decide on the type of X's that will be used in this discussion. So what factors do we include? Well, the following sources where brainstorming, as I mentioned, process mappings. Many teams will use process mapping to try to understand what affects a process. You might use the hypothesis testing. You might go back to the literature and see what other scholars and researchers discovered. Could be engineering knowledge. I mean, DOE is used for engineering design, for many complex engineering decisions. And sometimes when you have too many variables, maybe the team will have to select, go back to their engineering background, research, or actually previous data and select the right factors. So this is a discussion where you can have many variables, but then the question, which ones of these variables will have the biggest impact? The DOE will reveal what are these biggest factors. Choosing levels. The levels are the values we're being examined. So this is where what are we measuring? The time itself has two levels. If you're talking about brewing coffee times, right? So if brewing time or brewing coffee times, you have two different settings, two different times, then the factor time has two different levels. So if the brand in attributes have two, let's say, someone is saying, I want to check whether, the Starbucks or the Tim Horton is a better coffee when it has an impact on the Y, the quality or the bitterness. So the factor brand has two levels. This is what we call the levels that we will decide and will put in our data for the experiment. So now, when we talk about the discussion of coffee, one of my favorite topics, and of course, I do value a good cup of coffee, quality and not the quantity. So I'm always keen on knowing the ingredients and what makes a good coffee. So there is a question here, and the question is, let me take you to the survey and see what we see. So the question is, what is the most consumed coffee drink or drinks in the world? Is it cappuccino? Is it espresso? Is it Turkish? So what do you think the most consumed coffee in terms of the consumption. So if we look at that, all right, and let's see the results. So actually, it shows that cappuccino has the, as you selected, that it has the highest, what we call consumption. Let me share with you the results, all right, on that. And here are the results. You'll see that espresso is number one, Americano is number two, iced coffee. People like their coffee iced, and then cappuccino comes at number four. So you have, even the Turkish coffee comes at seven, and here is your source that you can actually check for this data. But it seems espresso, lots of espresso is being consumed worldwide, and this is the most consumed type of coffee. So to put all this in perspective, I like to practice. I like, to put this into action, and we want to decide on the coffee variable. So here is what we have. The experiment that we will have today is called Coffee Kaizen. Coffee Kaizen. So what we have, you're looking to improve the coffee in your office. You have a machine, and you have limited budgets. You're not going to go and change the machine. So you want to decide on the brewing time, the grind time. You want to decide on the amount. Should we use 1 cup or 1.25 or 1.5 cup? The type of beans, maybe you have types beans A, Starbucks, and then Tim Horton, which is type B. You have water, which is tap and bubble. So we're actually now engaging you in what we call the X's development. So Coffee Kaizen, changing it to the better or changing it to the good. This is what we seek to do now. And here's the coffee experiment. So the coffee experiment, what we want to do, we want to look at the following. Now, assuming that the team here decided that the following X's have an impact on the Y. Now, we'll talk about the Y in a minute, but the why could be the quality of the coffee. When you have a sip from your coffee, is it good? Is it quality? Is it bitter? Well, we have to decide on that and then quantify it, because when you give someone a cup of coffee and you tell them, well, what do you think of this? Give me a scale, 1 to 10. So this is where you're quantifying it. Now, how do we decide on the quality? Is it the bitterness of the coffee? Is it the aroma? Is it, how would you define that? Turning a subjective into an objective becomes important in these experiments, because we have to run that in the experiment and try to put a number to the Y. So assuming the team runs this experiment or plans to run this experiment, they discover that the coffee brand, you could have A and B. Starbucks is A, B is Tim Hortons, and then the package that you buy from the coffee place, how many days it's been open, days since opening the package. Will that have an impact? Yeah, many people will tell you, yeah, a fresh pack, definitely, if you open the pack, it will start to lose its freshness. So maybe 0 to 20 days is something that we can put in our experiment. Someone will come and say, what about the type of water? Is it tap or bottled? Does that have an impact? Yes, maybe, we don't know. Duration of bean grinding, there is a machine and we have to grind it. We have to tell the shop whether you're going to do it at the shop or whether you're going to do it in-house if you have the grinding machine. 1 minute or 4 minutes, will you get a fine sort of a grind or a more of a less fine? 1 to 4, I think here where the grinding itself may have an impact on the quality of the coffee. The amount of ground coffee placed in the filter, because you have put a filter or put coffee in the filter. So will you use a cup or maybe more, 1.25? So they decided on 2 factors or 2 levels. The number of cups in each pot. Every time you do a run, there will be a number of cups. So each pot will have 10 or 12. This might be a factor. So let's assume that the team decides they want to run this experiment. Here's our experiment, and they want to start playing with these factors. Now, the way to do this is you want to run an experiment and then get the feedback on your Y. So to do this, I will now take you into what we call the Minitab. So we'll start to go into planning the experiment. So this one is taken from the Minitab. So if you allow me, I'm going to take you to my desktop and then run Minitab and show you how we can basically do this together. So if we go to my desktop, right, and I'm opening now Minitab. Okay, so now you'll see when I go to the assistant up there, Minitab is a software that does lots of statistical analysis, and the assistant is a very smart area where you can basically do your DOE. So if you go to assistant and then there is DOE. So plan and create is where you want to do. Now, if you want to get actually your display better, you want maybe to do the following. You want to actually minimize your chat box. And let me try to do that from my end here as well. Okay, so you should have a better screen now. Okay, so the assistant here, once you go to DOE, you go to plan and create. And this is where the assistant is actually helping you to go through what we call the experiment. So the objective, you can click here and it will give you more information and example. But what we want to do now, we want to do design of experiment with a screening objective. So you go to create screening design. And here we go. So the response here is what you want to do is your why. So coffee. How would we measure that? Well, we said maybe we can put quality, right? We can put quality. Now, the number of factors that we previously identified, if you remember, were what? Were the grind, right? So the grind is continuous, and we said it could be 1 to 4, right? We also identified the age of the opening of the pack, and we can select here 3 to 20 days. You can use other things. Now the type, this is the type of information, the type of the X, and you have continuous or category. Category is like attribute. So continuous is on a scale. Category is like type A and B, right? So in this case, we can run 3, 4, 5, 6. So this is continuous. And then the amount in this case will be what? The amount of coffee you will place. Could it be 1 cup? Or maybe we can use as in our X's 1.25. How many cups you will run? So you have cups here, and you can use 10, right? You can use 12. You can use the type of beans, right? So you can say the type of beans is category, right? So it's the A and B, maybe Starbucks and Tim Horton. What I'm doing right now, I'm using Assistant in design of experiments to help me set up the collection or the data collection. Water type, this is category as well. So I could have tap water, or I could have what? A bottled cup. Now, once you do that, here it tells you how many it will run. Of course, if we take 12 runs, 12 runs in this case, and you just click OK, what the software is doing right now is actually telling you that here are my factors, the 6 factors that the team decided on. We're running 12 runs, and it tells you that you have 80% chance of detecting effects. So you have a good chance of detecting which ones of these 6 are the one have the main effect on the Y. And let me show you what happened here. It actually created this sheet. So you have here 12 runs, and then you have age, cups. So what you need to do, you start your experiment by saying, okay, I'm going to do now grind for 1 minute, and the pack will be 3 days open, and then I will use the number 10. I will use 10 cups from that run or experiment. The amount of coffee I will put, the type, this is Starbucks, this is staff. Now, this is where the experiment. We will need to take an output here, and we need to give it to someone so they can actually fill in. So if you say, I want to put quality, and you have to decide on the scale 1 to 10. So 10 being maybe the highest. Again, you have to define quality. Is it bitterness? How people would actually decide on that. So if you say 1 to 10, and you say, okay, you give it to someone and say, okay, this was 9.7, right? And maybe another someone will say this is 4.5. And you're basically filling in the details here. And this is where you have your data. Now you run your experiment. So what happens next? Well, we go back to my, okay, I'm going to go back to my slides. Okay, and my slides here are showing us that explaining what we just did, right? And my slides are showing that we are planning and creating the design of the experiments. And here is what I just did. So the slides are actually capturing what I just did. And here is my data collection. Quality 0 to 10. 1 is excellent, 10 very bad or bitter, or vice versa. You have to agree on this in the beginning. And then you basically, once you fill your details, so once your data is filled here, right, you will basically go and run something under the assistant DOE called analyze, right? And you will do the interpretation. So what happens next? Once you go to Minitab, right, and run this for the same sheet that we just filled together, right, you will get something like this. Now, Minitab will immediately give you this one, and it will tell you, based on the results that or the experiment that we have run, 3 factors were identified as critical: the grinding time, the type of the beans, and the number of cups per serving. Are you serving 10 or 12? So in this case, you can conclude that 3 of the factors in your model are significant. And these are the blue bars, basically, that are important. Now, how much of each, we don't know. That's where we come in to the optimization study in design of the experiment, where we start to understand what is important in terms of the quantity. So what is the type of the bean? What is the grinding time? We need to do that. What we did here, this is called screening model for quality or bitterness, if you decide that is the quality. And then you basically tell me that these are the 3 X's that are important for us. Now, what happens next after you've decided on that? We want to decide how much of each factor, how much of the 3 factors that I just looked at. So we go to the design, right? And we go to, let me show you that. So here's my desktop again. Here's my mini tab. So of course, you need to fill these details in. And once you have them, you can go to DOE and you will go to analyze and run your screening. This is where the identification of the critical bars will appear. Now we need to fill all of this together, and then, but you've seen the results over there. Now, the other one in DOE is what? Planning and creating, but we want to do now what we call the optimization. So from the 3 factors that we've discovered, we want now to create a modeling design. And this is where you tell me, what is your goal? Well, I want to optimize the quality of the coffee. And what is your response? Well, I want, again, did you decide on the quality that 1 to 10? 10 being the highest. So what you want to do, you want to maximize the response. So you want to say maximize quality because 10 was the highest. Now, the number of factors that we had were 3, if you recall. So grind, right? And 1, 2, 4, correct? And then we have the type of coffee or beans, and this is category. So is this Starbucks or Tim Horton again, or type A or B? And then the other one was what was cups, and this is where it's category, and it was 10 or 12 cups per serving. Now, once you do that, you're basically ready to create your your table. So the table that you will see here that was created, here we go, contains only the grind and the type and the color. Now, what we need to do, we need to actually play with them, well, run the experiment as per these, and then again put the quality here. So someone has to make this experiment using the settings here, and then give it the coffee to someone to tell me, is it 1 to 10, is it 9? So we have to measure that as well in the quality and plug in all the details, all the numbers here. Once you plug all the numbers here, you should have a data sheet, right? That data sheet, let me show you again. So that data sheet, you basically went here and you created what we call a data sheet. Now, as you see here, this is capturing what I just did, and then your numbers will be filled here by an actual experiment, giving it to maybe to people who actually are drinking coffee, and then they can basically tell you what is the quality of that coffee, so you can compare and you can plug them in. Now, once you do that, you're basically ready to move to the analysis. And this is done, again, through the assistant, where you go to the DOE, analyze, and of course, you will want to do now the fitting the quadratic model. And of course, we must fill in all the details. That's why the message, we have to actually put all the details, but this is already done here. So I did that for you, and then I got you the ingredients for the best coffee or the secret recipe for a coffee. So if you click here, you'll find that here is the recipe. It seems that the factors that are important here, right, as you see, design points with predicted Y, adequate. So grinding the whole coffee beans only for 1 minute and brewing only 10 cups per pot of coffee seems to be what the factors that are optimized to give you the best quality. Now, is that bitterness? Again, this goes back to the original display of the problem that you have. So what did we do here? We actually went through the X's, 6 of them, and decided that the 3 of them were important for us. Here in this case, we had only 2, but the previous example had 3. So whether you pick 3 or 2, again, this is the model where you are telling me that this is where the 2 areas here, again, depending on your model, did you pick 3 variables or 2 variables, doesn't matter. The software, the assistant will give you that what is the factor and how much of that factor you should have in your recipe for the best coffee. Once you do that, you basically have now run a design of experiments for screening the X's, selecting the X's, and then optimization study. As you see, Minitab has this great assistant, and it gives you these reports, and this can be run for any type of an experiment once you have defined your problem statement and your Y and your X's. The team itself has a big impact because they need to actually identify the X's, and then the experiment itself and the data generated from the experiment will actually determine the significant ones that should be later on optimized. So this is in a nutshell the design of the experiment and how it's run. I try to be simple and brief using the design of experiments using Minitab software, where many of these things can be manipulated and run very quickly. Of course, the experiment itself, the physical experiment, has to be conducted. It has to be conducted in a controlled manner, but then the data resulting from that experiment are fed into the Minitab and then run here. Now, why people fail in design of experiments in general? Well, the problem is not very clear. They're unable to quantify their Y's, or unable to identify their critical X's, inadequate brainstorming. They didn't cover all the bases. The results of previous experiments maybe are unclear. People think of it as a costly manner, but again, it could be sometimes time-consuming as well. They don't understand the tool to be used, whether the cause and effect matrix or diagram. no management support to give you to run these experiments, and someone just want quick results, instant result, and it turns into a guessing game rather than a scientific method to actually identify the factors and the significance behind them. So this is sort of a summary, the design of experiments and how it can be used in many of the projects of Six Sigma and Lean. It's widely used for engineering studies. It is basically, from the name, design of an experiment, where these experiments seek to optimize or improve or reduce, depending on your objective, a certain response, a Y, and then the study of the X's that you have in place. This is it for today. I hope you enjoyed the session. I hope I was able to simplify the topic and use it as a base for improvement and to simplify. We quality practitioners sometimes we're not very interested in statistics per se, but we're interested in the applications and how we can use it to actually get results to a practical problem or a solution for something that we seek to improve in our organization. Thank you. This is Fauzi here. And if you have any questions, let me know, or you can drop me a line or an email. If you get this webinar, for some of you who were unable to attend, send me an email or any inquiry, and I'll be glad to provide you with any support or more information. So if you have any questions, let me know. You can use the chat, and I'll definitely get back to you. If not, then you can always email me. And I'm sure the webinar itself will be emailed to you, so you can look at it again and then see if there's anything else that you want to be provided. Thank you. I'll wait if there's anyone who wants to share any feedback or any questions, and then we can stop and conclude. Okay, thank you very much. Signing off from Dubai. Thank you and have a great weekend.
Meirc.com